Hello, welcome back to Maths Marathon classes. This time I'll be taking a small part of vector algebra, one of the small important topic of vector algebra called as Lagrange's identity. Okay, very important identity for competitive exams like KCET and even for JEE, even for NDA exams. Many times questions are asked based on this Lagrange's identity, and you can see the statement for two vectors, vector A and vector B, we have magnitude of A cross B square plus A dot B square is equal to magnitude of A square into magnitude of B square, and various questions asked taken as examples here. 5 questions are shown here. I'll give the proof of this. This is the identity connecting both the dot product and cross product of the two vectors. We know the definition of the dot product or the scalar product of two vectors. A dot B is equal to vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta. Theta is the angle between vector A and vector B. We know that theta lies between 0 and pi, including 0 and pi. Using the definition of the dot product and also by using the definition of the cross product. In fact, magnitude of A cross B is equal to magnitude of A magnitude of B into sin theta. Using those two definitions, I'll be substituting on LHS and get the RHS. A simple proof, but you need to practice the questions. Many times simple questions are asked based on the substitution just. Okay, I'll give the proof of this. The Lagrange's identity for two vectors, vector A and vector B. LHS is equal to magnitude of A cross B square plus A dot B square. A cross B square plus A dot B square. What is magnitude of A cross B? Magnitude of A, magnitude of vector B into sin theta. Magnitude of vector A, magnitude of vector B, sin theta. Square is there, no? So square everywhere. Square it. A dot B is magnitude of vector A, magnitude of vector B into cos theta. Because square is there, square every term here. We get like this. And you can see that magnitude of A square into magnitude of B square is common. Magnitude of vector A square into magnitude of vector B square is common. So what remains is sin square theta plus cos square theta. Correct? Sin square theta plus cos square theta is 1. Correct? 1 into that number is itself magnitude. A square into magnitude of B square is equal to RHS. Hence proved. Quite simple proof by using the definition of dot product and cross product. We have this. Take some problems as I shown you earlier. Proof is given. Take down the question asked KCET 2025 recently. Okay. Magnitude of vector A is given. Magnitude of vector B is given. A dot B is given. Want to find the value of magnitude of A cross B. Very simple one. Just by using the Lagrange's identity. We have magnitude of A cross B square plus A dot B square is equal to magnitude of A square into magnitude of B square. Magnitude of A square, magnitude of B square. Magnitude of A cross B I have to find out. A dot B is given, substitute one by one. Magnitude of A cross B square, magnitude of A cross B square plus A dot B is 12, so 12 square is equal to magnitude of vector is given as 10, substitute 10 square into magnitude of vector B is 2 square. 10 square is 100, 2 square is 4, 12 square is 144. This is magnitude of A cross B square, correct? Keep as it is. Move this to right hand side. 100 into 4 is 400. 400 minus 144 is 256. So we get magnitude of A cross B square. Magnitude of A cross B square is equal to 400 minus 144, 256. Taking square roots, magnitude of A cross B is equal to 16. Don't write magnitude is plus or minus. Magnitude is always non-negative. It's either positive or 0, but can't be negative. Don't write plus or minus 16. Magnitude of A cross B equal to 16. Answer is option C. Question asked in KCET 2025. Simple question on Lagrange's identity. Take up the next one. This is a solution given to you. Question number 2. Magnitude of A cross B square plus A dot B square is equal to 36 and magnitude of vector A is 3. Want to find magnitude of vector B. Question asked KCET 2022. By using Lagrange's identity, we have by Lagrange's identity, magnitude of A cross B square plus A dot B square. Magnitude of A cross B square plus A dot B square is equal to magnitude of vector A square into magnitude of vector B square. We have this. Magnitude of A cross B square plus A dot B square is given to be equal to 36. Left hand side is 36 is equal to magnitude of vector is given to be equal to 3 square into magnitude of vector B square. 3 square is 9. So 9 into magnitude of B square. 9 ones are 9 fours are. So what do you get? Magnitude of vector B square is equal to 4. 36 by 9 4. So magnitude of vector B is equal to 2. Quite simple question. Answer is option D. Hope you understand. Practice these kind of questions. Solution is given to you here. Move on to the next one. Again, magnitude of A cross B square plus A dot B square is given as 144. Magnitude of vector A is 6. Want to find magnitude of vector B. We have magnitude of A cross B square plus A dot B square. Magnitude of A cross B square plus A dot B square is equal to 144. This is given like this. Magnitude of A cross B square plus A dot B square is equal to 144. We know magnitude of A cross B square plus A dot B square is magnitude of A square into magnitude of B square is equal to 144. Correct? This is left hand side. I am substituting the formula. Magnitude of vector A is given to be equal to 6. Magnitude of vector A is 6 square into magnitude of vector B square is equal to 144. 6 square is 36. 36 ones are 36 fours are. So magnitude of vector B square 144 by 36, that is 4. Correct? So magnitude of vector B square is 4, implies magnitude of vector B is equal to 2. Option D is the answer. Question asked in KCET 2020. Very simple question based on Lagrange's identity. Learn the formula. Okay, magnitude of A cross B square plus A dot B square is equal to magnitude of vector A square into magnitude of vector B square. Even in JEE exams, many times in the middle of the problem, we may require this. Okay, if they don't ask straightforward also, in the middle of the problem, we may have to use this. Okay, such kind of questions are asked. In CET, very straightforward questions are asked, very simple question. Solution is given to you here. Move on to the next one. Question number 4. Magnitude of vector A is 16. Magnitude of vector B is 4. Want to find root of magnitude of A cross B square plus A dot B square. Consider this and use the Lagrange's identity. Want to find magnitude of square root of magnitude of A cross B square plus A dot B square is equal to root of what is magnitude of A cross B square plus A dot B square. Using Lagrange's identity, it's equal to magnitude of A square into magnitude of B square, and square root of magnitude of A square becomes magnitude of vector A. Square root of magnitude of vector B square becomes magnitude of vector B. Correct? Magnitude of vector A is given to be equal to 16. Magnitude of vector B is given to be equal to 4. 16 into 4, 64 is the answer. Option C. Very simple question. We can do all these kind of questions in the mind itself. We can do mind calculations. No need to use pen and paper. Correct? Directly we can crack these questions. In 5 to 10 seconds we can get the answer. Correct? Not a difficult deal. 64 is the answer. Next one. Question number 5. The question asked in Common Key 2009. Vector u is given, vector v is given, magnitude of vector a is equal to magnitude of vector b is equal to 2. Want to find magnitude of u cross v. Okay, first consider u cross v, and answer is given in terms of a dot b. No, all the options contains a dot b. So first simplify what is u cross v. U is defined to be equal to vector A minus vector B. V is vector A plus vector B. Find out U cross V here. U cross V is equal to U cross V. Vector U is given as A minus B cross vector V is A plus B is equal to, take the cross product, A cross A minus B cross A cross A minus B cross A cross A minus B cross A plus A cross B minus B cross B. Correct? Taking the cross product, A cross A minus B cross A plus A cross B minus B cross B. A cross A is a zero vector. A cross A is a zero vector. Correct? Angle between same vectors is 0. Cross product means sign component. Correct? Angle between the same two vectors is 0. Sin 0 is 0. Cross product means sign component. Correct? Here B cross B is also 0 vector, because angle between vector B and vector B is 0. So that is equal to 0 vector. Sin 0 is 0. And minus B cross A is plus A cross B because of anti-commutative property of the vector. Correct? Minus B cross A is plus A cross B. A cross B plus A cross B becomes what? 2 times A cross B. So we got like this. Simplified form of U cross V. Now you take magnitude for this. U cross V, cross product of U and V, we got like this. 2 times vector A cross vector B. Taking magnitude on both sides, magnitude of U cross V is equal to 2 times magnitude of A cross B. By using Lagrange's identity, I can write this as 2 times square root of magnitude of A square into magnitude of B square minus A dot B square. Correct? Using the Lagrange's identity. This is equal to 2 times root of, what is magnitude of vector A? 2. Magnitude of vector B also 2. Substitute. 2 square is 4. 2 square into 2 square minus A dot B square. 2 into root of 2 square 4. 2 square 4. 4 into 4, 16 minus A dot B square. 2 times square root of 16 minus A dot B square. Answer is option A. Use of cross product, simplified, then take magnitude, then use the Lagrange's identity, get the answer. Magnitude of A cross B is square root of magnitude of A square into magnitude of B square minus A dot B square. Hence, we have done 5 questions. It's a short video. We'll conclude by this. Okay. I've taken just a small part of vector algebra, one of the most important topic in vector algebra called as Lagrange's identity. I explained what is Lagrange's identity with proof, and also we've done 5 questions on this. With this, we'll conclude. Thank you.